tonight's notes talk about rotations. We talked about them a little bit last class when we said that a composition of two reflections in intersecting lines is the result is a rotation. So a rotation is a transformation in which the figure is turned around a point. A rotation is also an isometry, just like the translation, the reflection, and the glide reflection. The orientation does stay the same. So far, the only transformation we've seen where the orientation changes is a reflection. All right, so this is a picture of a rotation where we have our pre-image and then the image has been turned. So we have a few different ways that we're going to rotate figures. We have an 180-degree rotation, which means essentially taking something and flipping it upside down. And we have 90 or 270-degree rotations. So we have different steps for each type of rotation depending on what we need to do. The 180-degree rotations are easier. We essentially just need to find the coordinates of any vertices of the figure that we're going to be rotating. All we need to do is switch the signs of those coordinates and then regraph the new points. Each point we're going to name with prime notation. In 90 and 270-degree rotations, we need to find the coordinates of all vertices again. Now, in addition to switching the signs, we need to switch the x and y values. We're going to determine the signs of the coordinates now based on which quadrant the vertices end up. So for example, if we're in like quadrant 1, where the x and y values are all positive, and we rotate it 90 degrees clockwise, we would end up in quadrant 4. In quadrant 4, the x's are all positive, but the y's are all negative. So any x values we're going to make positive, and any y values we would make negative if they were to end up in quadrant 4. If they were to end up in quadrant 3, we would make all the x's negative and all the y's negative. In quadrant 2, we would make all the x's negative, but all the y's positive. So it depends on where you started and where your coordinates end up in which quadrant. Finally, we're going to graph these new coordinates and then again label them with prime notation. So rotations will take some practice, but we'll do it, and as long as you follow these steps, you should have no trouble with it.